3, 2, 1. Okay, the question is, what is identity management and what are the main methodologies underpinning identity management? Identity management is, for me, a way in which we can synchronize and connect together different digital and non-digital identifiers in order to effectively resolve data sets, characteristics, and attributes across platforms, devices, and channels. So identity management is focused on our ability to be able to synchronize and our ability to be able to pivot and translate different identity ecosystems in order to connect together characteristics and attributes that are exhibited by individual consumers. The reason identity management is so important today is, well, there's essentially two reasons. One, consumers are engaging with media and with content in a completely different way today than they have done historically. We use more devices, we have touch points with more channels, and we exist and work through different platforms. So the consumer journey is essentially fragmented. It is very difficult to ascertain a holistic view across the various different devices and channels and touch points that an individual may have or go through on a path to purchase. So that's one of the major drivers behind identity management. The other major driver behind identity management is essentially the technology and the platforms and the systems that we use as marketers in order to be able to communicate and in order to be able to deliver messaging to consumers. And those technology solutions, those data solutions, those various different bidding platforms and those different systems also have to be connected, have to be integrated in order to facilitate a more seamless consumer journey, in order to be able to inform a more holistic and 360-degree measurement system. So you've got a proliferation in the devices and the platforms and the channels that an individual consumer will engage with or interact with through a path to purchase. And you also have a proliferation in the different data and technology platforms that we work with as advertisers, as agencies, in order to effectively deliver a media campaign. And both of those things in combination mean that, essentially the data footprint of an individual or a group of individuals is incredibly fragmented. It's disparate. It's spread across the ecosystem. And we need to find some way, at least in part, of bringing that data together so that we can inform a much better view of an individual consumer or a group of consumers for insight purposes, for targeting and activation purposes, for media decision, and for measurement and reporting. There are three different methodologies underpinning identity management: deterministic identity management, probabilistic identity management, and heuristic identity management. And those three different methodologies have different strengths and weaknesses. So I'll talk about each of those in turn, and then I'll talk about their different strengths and weaknesses. The first type of identity management is deterministic identity management. So deterministic identity management is focused on the idea that we can collect different inputs and different parameters from authenticated user actions across our first-party data sets in order to be able to connect different environments and platforms and devices together. So for instance, if I have a website and I have people going to my website, logging into my website, registering, transacting, etc., and providing me certain inputs, I can potentially connect those inputs to the way in which individuals are consuming media or working with my other properties, my apps, or my point of sale data sets. So for instance, if somebody comes to my website and they register using a username or an email address, and that username or email address is common across my app portfolio, or it's common across my point of sale data collection mechanisms, I'm able to effectively connect those different environments together using that common identifier, using that common key. So deterministic identity management is probably most commonly used for CRM onboarding. So from taking CRM data sets that exist within my CRM database and bringing those into a digital environment, into an environment that is principally cookie ID based or device ID based. So the idea is that if I have a CRM database and I have historical transactional information recorded within my CRM database, and I want to get that historical transactional information onboarded because I want to be able to use it within my digital media campaigns for targeting or for media decisioning, I have to find a way of connecting those two different environments together. Now, if I have people going to my website and registering or logging into my website and they use an email address and that email address exists within my CRM database, then I can use that email address as a key in order to connect those two different environments, and I can essentially onboard and transfer all of the historical transactional information that's stored in my CRM database into a cookie or a device ID ecosystem for use in digital media activity. So that's deterministic identity management. The second type of identity management is probabilistic. Probabilistic identity management, or probabilistic device graphing, as it's often referred to, is essentially a way in which we can use statistical modeling and statistical analysis over time in order to build correlations between different devices, and we can tend towards an individual level when we look at those correlations at varying different degrees of statistical significance. So the idea is that we can look at various different data inputs, and that could be device inputs, so the device make and model, the operating system, etc. We can look at consumption signals, which could be location signals like latitude and longitude, like IP. We could look at recency and frequency of visitation, those types of signals. And we could also look at behavioral signals, like the type of content that people are consuming and engaging with. And, all of those different signals can be used as inputs to a probabilistic device graphing solution, which will then use different statistical methodologies in order to try and identify correlations between different devices. So a very common example that's often provided is a household. And a household may have 8 different devices. So I may have 3 devices, my fiance may have 3 devices, and then there may be 2 devices that are common to the household. So a smart TV and a smart speaker. Now, over time, a probabilistic device graphing solution should be able to build a macro cluster of the household and the 10 different devices in the household. So it can see overarching correlations behind the ways in which these devices are being used. So the location data is fairly similar. The way in which the devices are connecting to the internet is fairly similar through the same IP, through the same Wi-Fi router. Information around the type of content that's being consumed, information around the time that the devices are being used will all be fairly similar. So there's a way in which we can start to build a macro cluster at the household level. Then what a probabilistic device graphing solution should be able to do is to build subclusters. So for instance, I take my 3 devices to work every single morning, and whilst I'm at work from 9 until 5, I register different location data, latitude and longitude. I register at a different IP. I register probably different content because I'm at work and I'm looking at different types of content at work than I probably would do at home. And my fiance takes her 3 devices and she goes to work also, and she's working at a different location to me, so she has different data sets on her location footprint. And over time, the idea is that a probabilistic device graphing solution can begin to understand and inform an assessment of the correlation between the devices towards an individual person. So that's the idea behind probabilistic device graphing solution. It's statistical analysis of big data inputs. It's longitudinal analysis. It takes place over time, and it's focused around this idea of macro clusters. And then from a macro cluster, we can establish micro clusters that trend towards an individual. Third type of identity management is heuristics. Heuristics is less commonly referred to. You're looking mostly at probabilistic and deterministic identity management when people talk about identity management, but heuristics is actually very important. It's fairly commonly used. So heuristics it's a similar methodology to probabilistic in the sense that it is statistical, but it tends to be a much more macro assessment of identity, and you're looking, generally speaking, at zone level, regional level, segment level onboarding and transfer of different attributes and characteristics through heuristics. So it tends to be a single data point or a single signal that is used to effectively onboard information about a segment or population of individuals. Most commonly, it's postcode or it's zip code. So it's a location signal that is fairly broad. It's at a zone level, and that is used as a proxy, as an approximation towards a given characteristic or attribute that we would like to have transferred or translated into an environment. So a great example is if I have a CRM database, and in that CRM database, I'm able to segment between my loyal and my non-loyal customers. And I'm also able to see the postcode associated to those loyal and non-loyal customers, then I will be able to build an index of loyalty against different postcodes. Now, if I register and recognize that postcode in a digital ecosystem associated to a cookie ID or a device ID, and that's going to typically be derived through some other location signal like a latitude and longitude, then what I'm able to do is start to connect and translate the loyal or non-loyal attributes onto devices that I recognize in given postcodes in a digital ecosystem. Now, clearly it's not an individual-based identity management solution. We're not connecting individuals. We're not using authenticated user action. We're not using sophisticated longitudinal statistical analysis. We're using an approximation based on one signal, in this case, the postcode, and on indexes that we have against that particular parameter. However, it can be fairly accurate, and it's fairly tactical. So there are certain attributes and characteristics. So for instance, household earnings tends to be a characteristic that is fairly well approximated by postcode. Type of home and home ownership is, again, fairly well approximated by postcode. Automobile ownership is fairly well approximated by postcode. So there are certain characteristics and attributes that can be fairly well approximated by a single data point that is readily available in both environments. And that's the idea behind heuristics. It's less accurate, but it's an approximation. So those are the three different identity management solutions, or methodologies rather. And in terms of their different strengths and weaknesses, so deterministic identity management is incredibly strong from the perspective of accuracy and efficacy. So you have an authenticated user action against your first party data set connected at an individual level. It doesn't get more accurate than that. Where it tends to struggle is scalability. So you only have so many people visiting your website, your mobile app, the various different properties that you own and operate, and providing that type of information tends to be a conversion metric. So most people tend to have kind of 2 to 5% of their online traffic actually delivering those matching keys through authenticated user actions. So it tends to be fairly low scale. Probabilistic identity management is a little bit more scalable because you're using different data inputs outside of just your first party data properties, but therein lies the rub. Dependent upon the data inputs that a probabilistic device graphing solution is using, and dependent upon the source, accuracy will wane, essentially. So if we have a probabilistic identity management solution that is working with a high volume of bid stream data, which tends to be a less accurate data source, then obviously the analysis that's performed on that data and the result that is derived could end up being ultimately less accurate. So there are questions to be asked around the accuracy of the probabilistic device graphing solution. And there are ways in which you can validate and audit those different solutions in order to ensure that they are high accuracy. In terms of heuristics, obviously The weaknesses are pretty self-evident. It isn't an individual-based match. It also uses approximations and proxies as opposed to using any in-depth statistical analysis or any kind of authenticated user action. The benefits, though, are that it is tactical, it is fairly fast to execute against because you're only using one or two different audience signals. And so it does have a role to play, and particularly when you're looking at some of those characteristics and attributes that I mentioned before, which can be quite well approximated by postcode or zip code or by another single data point.